Welcome everyone, my name is Mr. McGregor, and in this video we're going to be looking at work. At the end of this video, you'll be able to define the term work and use the formula work equals force times distance to calculate work, force, or distance. So let's start with an example. Here you can see a picture of a human cannonball. Now unlike normal cannons, this one doesn't involve gunpowder because that's just too dangerous. Instead there is a spring inside, and that spring is loaded up, thus storing elastic potential energy. And then the human climbs in, it's released, and that elastic potential energy is transferred into kinetic energy. So we get an energy change from the elastic potential in the spring to the kinetic energy in the cannonball. We say that some work has been done on the cannonball because there is a change in energy. But we can look at this another way. The cannonball obviously experiences an acceleration. It starts off with no movement, no velocity, and as it leaves, obviously it's got a large speed. How do we get an acceleration? Well, we know that there must be a net force acting. An unbalanced force creates an acceleration. And of course, in this case, that's the force provided by the spring. So we know there's been a change in energy, and we know there has been a force applied over some distance. And we can link these two things together using the idea of work. Work is equal to the change in energy of an object, and it's also equal to the force multiplied by the distance that that force moved. And this is a great concept because we can link all the stuff we know about energy to the stuff we learnt about forces and motion in the first part of the topic. So we can start with the change in speed, which we know results in acceleration. And if we know the mass, we can find the net force that was acting. And if we know the distance that that force acted, we can find the work. And if we can find the work, then we can find the change in energy that that object experienced. Work is measured in joules and given the symbol W. And note that that's got the same unit as energy. F is the force in newtons, D is the distance in meters. But the key thing is that the distance must be parallel to the direction of the force. And we're going to look at that a little later on. Here's the magic triangle for this equation. So let's go back to our human cannonball. And let's say that we're loading it up. If we apply a force of 100 newtons through a distance of 2.3 meters when the cannon is loaded, what is the work that's been done? Well, we simply take our equation, that the work is equal to the force multiplied by the distance. In this case, 100 multiplied by 2.3 meters gives us 230 joules. So what is the change in energy? Obviously that spring starts off with no potential energy, and as it's compressed it gains elastic potential energy. And that's quite simply 230 joules. 230 joules of kinetic energy from whatever it is that's pushing that spring down is transferred to 230 joules of elastic potential energy. And then when that is released, again 230 joules of energy is transferred from the spring to the kinetic energy of the cannonball. It's the same amount of energy each time, so long as we're not losing any energy due to heat and friction. So now you can define work as being the change in energy due to a force acting in a particular direction. And you can use the formula to calculate work, force, or distance, remembering that the force and the distance must be parallel. And the key thing about work is that it's that connection between forces and motion with energy and the change in energy of an object. Thanks for watching.